Working with databases is more complicated than local storage and session store, but it's the same basic principle. Here I've modified my sample.js file. We bind the same functions so that the form has its submit button hijacked and we call save settings, and we bind an animation start event to the load settings function. So that's all the same. But we need to set up our database connection. We need to give it a name, specify a version number for the database. This is arbitrary at this point, but it's so that the developer can maintain a record of which version of the database they're creating, version 1, version 1.1, as they go along and change the database schema. What should the database be listed as on screen, and how many records should the database be able to support? We then open a connection to that database and store our connection handle in the variable db. And then from that point on, the process is one of creating database transactions. Initially, whenever the document is ready, we conduct a database transaction. We execute a transaction that says create a new table if the table does not already exist. My table name is going to be faves, F-A-V-S for the moment. That table is going to have an auto-incremented ID value. It's going to have a name field, which will be text. It's going to have a color field, and it's going to have a food field. So if we take away the quotation marks and plus signs from this little segment, this is just an SQLite query. Our code says to go ahead and execute that transaction. So whenever our document loads, this database will be created if it does not already exist. And we can see that if we switch over to our browser. I have my blank page at the moment. If I load my sample code and open up the web inspector, I can see the databases. There's my test database and there's my faves table, currently empty. Notice that when I select test, I actually have a database prompt here. I can execute queries against the database. So I could select star from faves where, well, I'll leave out any clauses for now. Select everything from faves, end it with a semicolon. There's currently nothing in faves, so I get the empty set. When we go to our settings panel, the save settings functions are going to be called, the load settings functions are going to be called. So let's take a look at save settings. First, we get the current value in the name field and we just store it in a variable. We do the same for color and food, and then we execute a database transaction. Now these database transactions can be a little strange to look at initially, so parse them out carefully. The transaction, which runs from lines 40 to 52 here, takes a function, and that function takes several arguments. The first argument is the SQL that we want to execute, with question marks for the placeholders where we're going to fill in values. You may be familiar with this from other databases you've worked with. So I'm specifying that I want to insert into my faves table, into the name field, the color field, and the food field, 3 values, which I will then specify. The variable name, the variable color, and the variable food. So that's my second argument, an array of the values that I want filled in for the question marks in the order that they should be filled in. The third argument to execute SQL is a function to call once the insert has succeeded. In this case, I'm just having it go back to the main page. The fourth argument to execute SQL is the name of a function to execute in case there's a problem with the transaction. And here I've defined error handler at lines 30 through 33 to simply display an alert message showing me what the error is. That's save. It's basically just an insert statement wrapped in a database transaction. The load settings is the reverse of that. It's a database transaction also. It's an execute SQL statement, but instead of an insert command, we're using a select command. Select all fields, star, from faves, where ID equals question mark. That'll be filled in with the 1 that I've provided here. So in this case, I'm only selecting one record from my database, but I could perform any valid SQL select. If that select is successful, then this second function gets called. If it's not successful, then the third function gets called, namely error handler, which is the same error handler function as above. The success function is worth taking a look at here. On success, I'm going to get a record of the transaction and the actual result. The result object has properties like a set of rows that I can then iterate over. I can find out how long the list of rows is, and for each row, I can get the item in that row. So row here represents a single row out of the database, out of the select results. I can then just access the properties on that row. The properties map to the fields in the database. So row.name is the name field from that row. And I just set the value of the name field in my HTML form to that value from the database. Similarly for color and food. Let's take a look at this in action. So faves has been created, but it's currently empty. When I go to the settings panel, there's currently no data in my system. I'll add some color, some data, William, blue, water, and I'll save it. And if I switch away from that and back to the faves database, we can see there's a record now. When I go back to the settings panel, that record should be looked up and those values should be filled in, but let's convince myself of that. I'll execute an update from the console. Update faves set name equal to Will, comma color equal to red, comma food equal to pasta, where ID equals 1. So again, I'm affecting just a single row here, and I'm updating the values to 3 different values so that I can see that taking effect. And if we looked at the faves database here, we can see those new values have been stored. And when I go to the settings panel now, I should expect to see those new values. And there they are.